You want to read the problem carefully, obviously. Pick out the key information. Then you have to determine the appropriate formula. Keep in mind we're working with series and sequence, arithmetic series, geometric series, arithmetic sequence, geometric sequence. Write down what you're given. Okay, if they tell you the first term, you know your A value. If they tell you the common ratio, you know your R value. If they want a specific term, then solve for that specific term. Okay, you will be given the formulas for the test in this unit. That's a question we did last class from the previous night's homework. Here's the first question. Now, I won't bother getting you to write this down. Okay, I'll get you to write the next example down. Let's just try and work through this together. It says for a compact car, the cost of maintenance and repairs increased by $85 each year. If in the first year the amount was $120, how much was the maintenance at the end of year 5? Okay, first of all, let's try and figure out, one, what type of series or sequence this is, and two, write down our given information, and three, let's solve for what they're asking me to figure out. So when you read that, is there anything that stands out? 120 is the A. Excellent, Brody. Okay, the first term would be 120. Now, it increased by $85 each year. That means like in year 1, it would be 120. What would it be in year 2? 205. What would it be in year 3? 290. In year 4? 375. And then what would it be in year 5? All right, we'll carry on. That's how the sequence goes. I think you can agree that if it's increasing by $85 each year, I'm adding 85. So it has a common difference. The D value would be 85. Any issues with that? And to answer this question, how much was the maintenance at the end of year 5? Term 1, term 2, term 3, term 4, term 5. What would the answer to that question be? 460 what? Dollars. Good. Okay. Now, if you wanted to use the formula to solve it, I should still get the same answer, 460, but this is what it would look like. I would replace the ends with 5s. So term 5 is what I was looking for. I would replace the A with 120 and the N with a 5 and the D with an 85. Solving this, I would figure out that term 5 is equal to 120 plus 4, do your brackets first, times 85. Then I'm going to multiply. 120 plus 485 would be 320 and 2340. Add 120 and 340 to get 460. And to finish this question, I would write the following. The maintenance cost would be $460 at the end of year 5. Cool? All right. The next question, I will get you to copy this down. All right, so I'm going to pause the video. Okay. All right. We have a house worth $70,000. What does the 70,000 represent? That's your A value, wicked. So it was worth $70,000 when you first purchased it. Now check this out because this is kind of crazy. It says 3 years later. So 1, 2, 3 years later, what's the house worth? $105,000. So they're actually telling me term 1, or A. But what's this represent? Term 4. That's right. It says find the annual rate of increase if the value of the house increased geometrically. What is this telling me if it's geometric? Common difference or common ratio? Common ratio. It's got an R value. I don't know R. Okay. I'm going to find R, and then I'm going to show you what to do with the R value in order to get the annual rate of increase. So if I wrote down my given information, what would you say the A value was? 70,000. What's the N value going to be? 4. Even though it says 3 years later, it's actually the 4th term. What was T for? Awesome. And what's the R value? That's what we're looking for. Anyone know what the formula for a geometric sequence is? Tn equals A times R to the power of n minus 1. First thing I'll do is replace the n's with a 4. I'll replace the A with a 70,000. Don't know what R is? That's what I'm looking for. T4. What can I replace that with? 105,000 equals 70,000 times R to the 3rd. Now, if you wanted to solve for R, what would you do? Divide both sides by 70,000. Excellent. 105,000 divided by 70,000. 1.5. And over here, I'd have R cubed. This 70,000 divided by 70,000 will be a 1. 1 times R cubed. Now, if I wanted R by itself, what would I do to the 1.5? Take the cubed root of it. What is the cubed root of 1.5? If I go to 4 decimal places, what do I get? 1.1447. Yes? That is the common ratio. So if I took 70,000 and I multiplied it by 1.1447, and then took that term, the second term, multiplied it by 1.1447, and then took the third term and multiplied by 1.1447, I'd end up with something very close to $105,000. Not exactly $105,000 because I rounded, or I only went 4 decimal places. Cool? But the question doesn't ask for the R value, the common ratio. It asks for the annual rate of increase. This is how you find the annual rate of increase. So the annual rate of increase, it's a percentage. I'm going to call it the AROI, A-R-O-I, annual rate of increase. It's equal to 100 times your R value subtract 1. In this case, that would be 100 times, what's my R value? 1.1447. Do your brackets first. That would give me 0.1447. If I multiply that by 100, I end up with 14.47%. That means that the value of the house increased by 14.47% per year. Annual rate of increase every year. So a couple of things. All right. To answer the question with a sentence, I would say the annual rate of increase is 14.47%. I'm not too picky about the sentences, but you should always write a little statement. Okay, they wanted the annual rate of increase. That's what it is. Little chart here. when R is equal, when the common ratio is equal to 1.1447, what was the annual rate of increase? 14.47%. What if the R value is 1.2? Anyone have an idea what the annual rate of increase would be? 20%. Good, Brody. 1.35, what are you going to get? 35%. Cool. You can see the pattern, right? It's just basically take the decimal or whatever's after the decimal point and multiply it by. But really, the formula is this. Okay? What would this be? 6%. Good. What about this one? What's 0.9 minus 1? Negative 0.1 times 100. Negative 10%, right? Okay. That's not an annual rate of increase. This one would be an annual rate of decrease. It's going down 10%. What if it's something like this? What if it's 2.36? Subtract 1. What's 2.36 minus 1? What's 1.36 times 100? It would go up 136% every year. Okay? It doesn't have to be a percent, like something between 1 and 100. It could be, in this case, 136%. Is that okay? So be careful when you do that question, the n value. When they see that, a lot of people see the 3, they think n is 3. If it said 5 years later, well, I'd be actually, they'd be telling me term 6. Final question. Final boss. Word problem, final boss. You have this one. As it aged, a maple tree produced sap according to the pattern shown below. Now, note on your sheet, that's not 60,000, 57,000, 54,150, and so on. This is actually 60.000, 57.000, 54.150 liters, 51.4425 liters. Does the data follow an arithmetic or geometric pattern? Well, let's see. If I subtract, what's term 2 minus term 1? 57 minus 60, negative 3, yes? If I subtract here, term 3 minus term 2, I get negative 2.85. Is it the same number? We're not going to say it's close enough. I'm not rounding. It's not the same, is it? So if it doesn't have a common difference, we can rule out which one, arithmetic or geometric. It's not that. Let's check to see if it does have a common ratio. What is 57 divided by 60? Try 54.15 divided by 57. Okay. And then try 51.4425 divided by 54.15. So does the data follow an arithmetic or geometric pattern? What would you say? It's geometric. Why is it geometric? Because R, 57 divided by 60, 54.15 divided by 57, or 51.4425 divided by 54.15 is equal to 0.95. If I were to write down a formula for Tn, what's the formula for a geometric sequence? Tn is equal to A times R. Attaboy. Tn is going to equal. What would I fill in for A? Anyone know what the first term is? 60. I don't have to write 60.000. I can just write 60. And I fill in 0.95 for R. And that's it. That's the general term. And look at, if I wanted term 1, I'd fill a 1 in for N. 1 minus 1 is 0. 0.95 to the 0. Anything to the power of 0 is 1. 1 times 60, I would get 60. If I wanted term 2, I'd fill a 2 in for the N's. 2 minus 1 is 1. 0.95 to the power of 1 is 0.95. 0.95 times 60 would give me 57. I could generate any term. And I'm not going to clean this up. Like, yes, I could express them with a common base, but I'd end up with some weird, wacky decimals. So I'm going to leave it as is. And under no circumstances should I multiply the 60 by the 0.95, because you can't multiply before doing your exponent. So there is my formula for Tn. One final question. It says, assuming the pattern continues, how long will it take for the sap production to be approximately 17.5 liters? What are they asking me to solve for, and what are they giving me? What does the 17.5 represent? It's an amount of liters. How long? What do they want to know? They want to know N, Brody. Good. So if I'm going to take this formula right here, and I know A is 60, right? And I know R is 0.95. And Brody just told me that they're asking me to solve for N, so I can't replace that with anything yet. In order to solve for N, I need to know A, R, and Tn. What's Tn in this case? Good, Brooklyn. 17.5 would go here. What's the move? Multiply those together, call it 57 to the power of N minus 1. No. Divide both sides by 60. 17.5 divided by 60. Anyone? .2916 repeating, right? What's the move now? How do I solve this exponential equation? When I'm looking for N, the variable N, and it's in the exponent, I get a common base, Brooklyn. So look at your base on the left, 0.2916 repeating, and then 0.95 on the right. What's the base I want to use? 0.95, wicked. So I'm not going to change the right-hand side. A little bit of a drag there. How do I change this to a base of 0.95? I'm going to do the log of 0.2916 repeating. Okay? If you don't want to use that decimal, like if you just use 0.2916 and say Caleb uses 0.291666666, he goes wild on the 6, you're going to get a different answer. And it will vary depending on the number of 6s you use. If you want to put 17.5 divided by 60 in there, that's great. That's an exact value. But what do you divide by? And what do you get for an answer? Point what? 0.2. So if I do on the log of, I'm going to divide that by the log of 0.95. I've got 24.0215. Does that look okay? What do I write here? 0.95 to the power of 24.0215. That's just a fancy way of writing 0.2916 where the 6 repeats. Agreed? And now what can I do? I can drop the base from both sides, set the exponent to 24.0215 on the left, equal to the exponent n minus 1 on the right. I will add 1 to both sides, or move the negative 1 from the right to the left, and I would get 25.0215 equal to n. That's great, I solved the problem. Now let's write a sentence to answer the question. What was I figuring out? How long will it take for the sap production to be approximately 17.5 liters? I would say it will take 25.0215 what? Years for the sap production to reach 17.5 liters. Or you could say it would take approximately 25 years. Is that okay? Awesome. You have a worksheet to do for homework. These are the formulas that we will be working with on that worksheet. Okay, arithmetic on the left, geometric on the right. Arithmetic have a common difference, geometric have a common ratio. Don't forget about your sum formula for a series. Okay, good luck. Go to work on those.